All right, let's talk about AI. It's everywhere, right? But what is it really? Today, we're going to pull back the curtain. By the end of this, you'll go from just using AI to actually understanding it, ready to ask the tough questions about the technology that's shaping our future. So here's how we're going to tackle this. First, we'll get on the same page about what AI is, and more importantly, what it isn't. Then we'll peek under the hood to see how it works before we get into the really big, important stuff everyone's talking about, like bias and how we can build this technology responsibly. Okay, so first things first. Before we can even dive into what AI is, we really have to get clear on what it isn't. And that means we've got to bust a pretty big myth right off the bat. Think about it. What does intelligence even mean to you? Usually we think of it as, being able to learn, to adapt, to truly understand something. But can we really apply that same idea to a machine? And this right here is the absolute key. The definition says AI systems appear to mimic intelligent behavior. See those words? Appear, mimic? That's not an accident. AI isn't conscious, it's not self-aware, it doesn't get things the way we do. It's more like it's a phenomenal actor, just simulating intelligence. Okay, so how do these things actually, think? Generally, there are two big ways they go about it. Let's start with the classic, kind of old school approach. Okay, check this out. Imagine you have a piece of paper, and on it is a cheat sheet for tic-tac-toe, just a list of rules. And if you follow these rules perfectly, every single time, you will never, ever lose. You'll either win or draw. This is a perfect, simple example of what we call a rule-based system. So you look at this and you think, wow, that piece of paper is a genius. It never loses. But is it really intelligent? Is it actually thinking up strategies? Or is it just, blindly following a script? Yep, you guessed it. Of course it's not intelligent. It's just a classic rule-based system. It's all about if this, then that. It can't adapt to anything new. And that is the polar opposite of how most modern AI works. Today's systems are data-driven. They don't follow a fixed set of rules. Instead, they learn to make predictions by sifting through mountains of data to find patterns we might never even see. Okay, so let's get into the really cool stuff. How does this data-driven approach, which we call machine learning, actually work? This is the powerhouse behind pretty much all the AI you bump into every day. Machine learning, at its heart, is all about a huge shift in thinking. Instead of writing a massive list of rules for the computer, like with our tic-tac-toe game, we just let it figure things out from examples. So a really common way this happens is through something called classification. Just think of it like sorting things into different buckets. We show the system, say, thousands of pictures that we've put a label on, saying this is an apple, and thousands more labeled this is a banana. These labels tell the model which class or which bucket each picture belongs to. And the rhythm is pretty much always the same. First, we train the model with all that labeled data. Then, the model learns the patterns. And finally, we give it something new, something it's never seen before, and it makes a prediction, usually with some kind of confidence score. This simple-sounding process is what's running everything from your email spam filter to really complex tools that help doctors diagnose diseases. Now, there are tons of different kinds of models that do this. One of the most popular, especially when you're starting out, is a decision tree. And people like it because you can actually understand what it's doing. It's not a total black box. It basically just asks a series of simple yes or no questions, like a flowchart, to get to its final answer. But here's the catch. This whole amazing process, it's completely dependent on the data we feed it. So, what happens when that data is, just plain wrong or biased? Listen, if you remember one thing about AI ethics, make it this. Bias in, bias out. It's that simple. An AI model is only ever as good or as fair as the data it learned from. You put garbage in, you're going to get garbage out. Okay, let's play this out with a quick thought experiment. Imagine we're building an AI to suggest what job someone might be good at. Sounds useful, right? But what if we train it only using job data from the 1960s? Now just think for a second. What was the workforce like in the 1960s? If you ask that AI about the job nurse, what gender is it going to associate with that? What about professional football player? The AI's isn't being malicious. It's just going to perfectly mirror and even amplify the stereotypes that were baked into its training data. So this little experiment shows us two huge problems. The first is data bias. This is when your data just doesn't show the whole picture. Like if you tried to teach an AI about apples but only ever showed it pictures of green ones. The fix, well, you need bigger, more diverse data sets. But the second one, societal bias, is way trickier. This is when the data is accurate, but it reflects the unfair prejudices that already exist in our world. And solving that, that's not just a data problem, it's a human problem. A big first step is making sure the teams who build this stuff are as diverse as the people who will use it. So, if getting rid of bias completely is, well, pretty much impossible, what do we do? Just give up? No. The focus in the field has really shifted towards creating frameworks and guidelines for building AI in a more responsible, more thoughtful way. One really practical tool for this is the FATPS framework. You can think of it as a simple ethical checklist to run through for any AI system. It forces developers to stop and ask the hard questions. Is this thing F for everyone? Who's accountable if it messes up? Is it transparent about what it's doing? Is people's privacy being protected? And how secure is the whole system? Okay, let's bring a principle like transparency to life. Picture this. You're scrolling through your feed and you see this shocking video. It's a celebrity and there's audio of them admitting to something awful. It looks real. It sounds real. Everything about it seems legit. This is exactly where we need tools for transparency. And then, right below the video, a little box pops up. It's from a tool, let's call it Check AI, and it just says, the audio in this video has been partially generated by AI for the purpose of reenactment. Boom. That's the power of transparency. It's not telling you what to think. It's not saying the story is fake. It's just giving you that one crucial piece of context so you can be a smarter, more critical viewer. And that's really what this is all about. When you understand the how these systems learn, where bias comes from, what a framework for responsibility looks like, it empowers you to start questioning the why. We can all stop being just passive users and start being active citizens in a world that's being reshaped by this technology. You know, this stuff isn't just for the computer scientists and engineers anymore. It's for all of us. Whether you're an artist, a doctor, a designer, a scientist, AI is going to be a part of your world. It's going to be in your toolkit. So the real question for you to think about is, what problem in your world could it help you solve?